We ready to get started?
We're at 2 o'clock.
All right. Good afternoon, everybody. Welcome to the October 10th Hanford Advisory Board Tank Waste Stewardship and Treatment Subcommittee meeting. My name is Leslie Summers, and I am the DDFO for the Hanford site. A few reminders before we get started. All of our meetings are conducted in accordance with the Federal Advisory Committee Act, and each member has a joint responsibility for assuring that the operating ground rules are observed and discussions are conducted in a respectful manner. I appreciate your attendance today, and Josh, I'll turn it back over.
Couple of administrative items. You've all heard it several times already in the last 2 days. We have a sign sheet up front. Appreciate you signing because you track that. If you're online, you're invited to enter your name and affiliation in the chat. So before you pressure, these will be recorded and posted to the Hanford site YouTube channel. We have attendance online. So counterintuitive, and then you see them over here, but hear them and speak to them over here. So please direct your voices towards the center. And with that, we can hand it off to our chair.
Hello, welcome to the tank waste treatment and infrastructure. Gosh, I can't remember the name. Stewardship. Stewardship, yes, twist. It used to be so much simpler, like TWST. So we've been asking for a number. We've had over the years a bunch of presentations of the tank farms, what's been happening at the tank farms. And this is really a furtherance of the general knowledge of what we're doing out there in the sake of tank integrity. We've asked a number of questions over the years. We've got answers to many of them, though some of the very troubling ones are life extension, repairs, and things of that sort. And so we recognized a couple of years ago that Savannah River had been working on repairing some of their waste tanks, and then asked for some level of accreditation here. And that's what this presentation is basically about, working towards extending the life of a double shell tank so it can complete our mission at the rest of the plant. So go ahead and introduce yourselves, please.
Yeah, so I'll briefly start. Hi, everyone. My name is Eric Nelson. I'm with the Department of Energy, managing the tank and pipeline integrity program that WRPS operates.
Cale Boomer, I'm the manager of technology management and field solutions, and this is one of our field solutions that we're working on.
And then I'm Stephanie Bell. I'm working in the Chief Technology Office on this project called Great Technology.
And Rob, before they get started, you want to go around the room and do introductions?
Oh, yes, we should try to do that. I just get right to the business down there.
Get so excited.
My name is Rob Davis. I represent the city of Pasco.
Larry Brand, Public at Large.
Josh Patnoy, the HAB facilitation team.
Chris Sutton, Local Environmental Interest. Ed Parson, Public at Large. Jim Doherty, HAB member from the Oregon Hanford Clinical.
Mia Burke with Hanford Challenge. Laura Caulfield, Katmai.
Marianne Wanacke, HMIS. Lindsay Summers, DOE.
Matthew Campbell, Federated Tribes, Utah.
Here again, employee, non-union, non-management.
Kathy Dubois, non-union, non-management.
Bob Quirk, member of the public, not a member of the HAB.
Derek Sally with WRPS.
Jim Alzheimer, public. And my name is Mike Leonard, work for WRPS. I'm the manager of projects engineering and CTO.
And short side and engineer with CTO.
Chandler with HAB facilitation.
Now, go down our online participant list. When I call your name, you can throw it open the microphone and make a research on it. We'll start with Ambika.
Jim Conca, Tridec.
Dan Solitz, member of the public.
Dave DeSimone, Department of Ecology.
Rob Parmalee, non-union, non-management employees.
Catherine Glick, hydrogeologist, nuclear waste program.
Yeah. Matt.
Matt Hendrickson, Oregon Department of Energy.
Jane? Dan McDonald?
Dan McDonald, Ecology.
Dana?
Dana McFadden, Ecology.
Brian? If you're able.
Ryan Miller, Ecology.
And Steve?
Steve Needles, Department of Ecology.
So Tom Rogers online, who notes that we have a broken microphone and can't introduce himself. That, I think everyone will introduce themselves. I'd like to hand it over to you.
Yeah, no, appreciate it. And thanks again for having us to share this topic with you. This is something that I think we've mentioned once or twice before in some of the broader context of the Think Integrity meetings that we've been keeping you guys up to speed on, but figured it was important for us to get in a little more detail, provide a little more context as to what that development process looked like, what the tool is, the development that was behind it, and where we're at with that right now. So I'll provide a little bit of a high level overview of what cold spray is. So cold spray itself is what we call an additive manufacturing technology. It's something by which you take a metallic powder, accelerated at supersonic speeds onto some surface. It then hits that surface and actually bonds with it to form at least thicken whatever you're applying that the surface to. Now that has a lot of advantages for us here at the Hanford site. Interest in the sense of management of our double shell tank systems. Our DSTs, been in service for decades, can experience corrosion, and so to have a technology where we can actually go in, deploy the system, and spray down local portions of this material to build up material thickness in those areas is of great interest to us. We started back in 2019, and Stephanie will go into some more of the detail behind the development process itself. But about 2019, we started looking at some of these technologies and developing them over the past 5 years. The robotic systems have gone into it. The formulation of the cold spray powder itself, and it's all culminated into what we've got to share with you today. So if you're good with that, Stephanie or Joe.
A tool in our toolbox.
Yeah, just another tool in our toolbox.
Yeah, basically this came from a recommendation out of the Tank Integrity Expert Panel, and if you're familiar with it. Some of the people that are on the panel are Jerry Frankel, who's a world-renowned corrosion chemist, John Beavers, Bob Sindel, another co-chair, Todd Martin, another co-chair. Andy Duncan is a material scientist from Savannah River. Dennis Wachenfelder provides the local flavor. You may know him. And a few others, but a very well-rounded, very highly, I want to say recommended, highly renowned group of people. So, Stephanie came to work for us about the time we were starting up this project. So it was a natural thing to turn the project over to her. And the project, though we started investigating since 2019, this project we started up in earnest in 2022. So turn it over to Stephanie.
Yeah, so I want to thank you guys for the opportunity to talk with you today. So I'm excited to share some, sorry, please speak up. I'm excited to share some of our successes that we've had with this to you guys in this cold spray technology development. WRPS has gone from, so actually, let me go back up. So at the end of this discussion, I do want you to be able to walk away with 3 things. And I'm going to prompt you on what I think those things should be. So if you're looking for them, one that it has taken us just a little over 2 years to go from a concept to a working system out in the field, which I think is great with that short time span. 2, that I want you to see this on your own, but tell you that we have utilized a robust and thorough approach at developing this technology. And then lastly, I want you to see that this technology has the capability for being used to help refurbish our thinning on our double shell tanks. So first, I want to just discuss a little bit about the technology itself, what cold spray is. So it's been around since the 1980s. And since that time, it has really evolved tremendously in its development. Cold spray is being utilized in a variety of industries, including the Department of Defense, the automotive, the oil and gas, and power industries, to name some of the top players. And with that, I'm gonna give you one example that illustrates cold spray really well. And it's with the US Army. So the US Army is using cold spray. They've identified that as their preferred solution to corrosion and dimensional restoration. And since 2007, they have been using cold spray to repair worn out and corroded magnesium gearbox housings on their Black Hawk helicopters. So that's been since 2007, we're now 2024. So it kind of gives a little impetus that this is a technology that has been around and it is well developed. And now we're just modifying it to our application. So what I want to go over next is a little bit more of the chemistry. So if we could have that first slide. And yeah, so you can play this now if you can. So I just want to show you the cold spray deposition process. And I found this video to be beneficial. I'm a very visual learner, and so I hope that this can assist you guys as well in seeing this process. And it might have sound, so you might want to not play it. It's a stationary cold spray setup. Okay, so it's going to zoom in on the heater, which you will see gas going through and then going through the heater, heating up, and going out through the spray nozzle. So the thinner section is a spray nozzle. So with cold spray process starts by heating up a pressurized gas. In our case, we are heating up nitrogen gas to 650 degrees Celsius. Once that desired temperature is reached, then a metal powder particles are introduced into the spray nozzle and they exit at supersonic speed. And the cold spray coating, it's actually formed through ballistic impingement of those materials onto that subsurface. Now with this deposition occurs at a temperature well below the melting point of this metal powder. And so this generates no heat affected zone. There is virtually no time for oxidation or for particle phase transformation. So that is, yeah, so that's the cold spray process. That's about the extent of the fine details of cold spray I'm going to get into. What I want to discuss now is the evolution of our cold spray at WRPS.
I noticed that it's a fun, I guess, light, so it is machinable.
Yeah, so it depends on the application type. If you want to if you want to build up a layer and then you want to machine it down, you can do that. It's one technique that's used out there. You can also just apply it. What we are proposing is to apply it robotically, which has a more consistent finish, so you don't need to go back in and machine over top. So with this next slide, this on the left-hand side or on your handouts, the picture on the left, this is the proof of concept demonstration that was conducted in 2021. This was to demonstrate and verify that commercially available equipment could be used to refurbish a tank. So this tank is 1/10 the scale of a primary shell tank. We developed a system to spray mild steel onto this. And what I want to point out to you, and I'll be the best I can for those who are online. You have your robotic system in the bottom left-hand side with that. It's a square black box with the orange, that's an orange 6 degree of freedom welding arm. On the end of that arm is a spray nozzle, which is hard to see. And that's mounted onto that black box, which is your mobile robotic platform. That robotic platform has permanent magnetic wheels to allow this system to adhere to the sidewall of the tank. This is also connected to two systems that remain at grade level. This is your powder feeder. Remember, you have to have that powder material go through that spray nozzle, and that's our feeder. So that's, these two systems were at grade level. Since then, like I said, when I joined in 2022, we started the development program for the system that could be deployed into the Hanford tanks. So proof of concept basically showed that it worked, but it's in a size that's not conducive for application and for our purposes. So we needed to repackage that cold spray system so that it could actually be deployed through a 24-inch riser. So we had to make sure that we could significantly reduce that size. We also made some adjustments to that by reducing the overall size and weight of the heater. So the big box in the proof of concept image that says BRC on it, that houses our heater. We reduced that size of the heater and incorporated it onto our final wall crawler and floor crawler. It's covered in a black shroud, is what you see for the heater. That heater, though, does weigh 28 pounds. So we did need to increase our magnetic pull strength from those 4 permanent magnetic wheels to suspended magnets instead that had greater pull force to keep our system adhered to the sidewall. We also upgraded that 6 degree of freedom arm that had the nozzle at the end. We exchanged that with a raster system. So the raster holds the nozzle and it just goes back and forth while the cold spray is being applied. So that's the difference there. So got that a little bit compacted. And once we completed our wall crawler design, we then moved on to the floor crawler. So the wall crawler is designed only for adhering to the sidewalls to do sidewall refurbishment, while the floor crawler, we needed to have a smaller system because we only have 18 inches of flat space on the annulus floor in that 30-inch annular space. But so we needed to compact that system down, and that took us a little less than 6 months to complete. So the success with that is that we use basically the same components, just in a slightly different configuration. So it works the same. Next slide, please. So in parallel to developing the equipment, we also perform corrosion testing to assess performance of the cold spray patch, be it within the annulus environment, or if it were to actually come into contact with tank waste. We wanted to know how that patch would effectively respond. So we performed accelerated corrosion testing, and the types of corrosion testing we investigated included cyclic polarization, galvanic corrosion, alternative immersion, slow strain rate testing, and then we also looked at hydrogen enfrielment testing. And we started with 8 coating candidate materials that included mild steels and stainless steel, and we narrowed that down to the 410L stainless steel as being the ideal feedstock for Hanford site application. So I want to highlight the collaborative effort that went into these studies. We had input that came from Savannah River National Laboratory, the University of Alabama, EMP Laboratories, BRC Metal Systems, which was our subcontractor who performed the work, and then also the Tank Integrity Expert Panel Corrosion Subgroup. So there were a lot of people involved. Let me see what the slide is. Yes, next slide. So to validate the development of our technology, we conducted 8 demonstrations between November of 2022 and May of 2024. And 4 of those demonstrations were held at the cold test facility. And I heard that the HAB group actually got to visit the cold test facility. That's an amazing facility. I'm glad you're able to. So what I want to do is to show you a short video of the third demonstration, not this one, because I don't have time. We can come back to it. The next slide, please. And then I'm going to talk a little bit before you play the video. So I'm just going to talk to what you're seeing here. So what you're seeing before we play the video is the crew that is setting up on the mezzanine, so the level above the tank. And so if this were out in the field, then this would be at grade level. Okay, so where this gentleman is standing in the camouflage pants, right in front of him is a 24-inch riser in that floor. And then we have a hoist that is situated above the riser, and that is for deploying our cold spray system down into the riser and the annulus at the bottom of the tank. Something else that is shown here, and I haven't mentioned it, is this Raptor control box. This control box is needed for communicating with our robotic crawler, and it's needing to be close to the riser. It houses the powder feeder. It also connects the gas, electrical, and communications, and it links that to the crawler by use of an umbilical. So you will see that umbilical. It's going to be a big black cable that you'll see in a picture, and I'll try and point it out, but it goes by a little fast, so giving you a heads up. So if you want, you can continue on now, the video. So it starts out with the gentleman just connecting the electrical to our Raptor box. That's where the system is being deployed through the riser. So you can see that it is a constrained space that we're working with. And then once the system is deployed to the annulus, with that wall being our mock annulus wall, the tray braces itself up against it and our system drives off. We were able to show that our wall crawler could withstand the weight of 100 feet of tether. So the maximum distance that the system could go in the tank. We then positioned the crawler to a location a desired location to start spraying. And what I want to talk to, which is not shown, is that we perform coupons. We spray coupons in the field before and after we actually spray the true patch. And that way we can analyze if the system is performing as anticipated and desired. And so this is one such coupon that you would see, or that you would generate out in the field. So this is a mild steel with 410L stainless steel on top. So you can pass that around and see that coupon material. So again, that's the stainless steel on top of a carbon steel. That specific coupon was generated early in 2023. And so we have since performed some improvements on our powder feed selection and those material properties. So we have refined that surface finish to be a little bit smoother. And then this is the final slide. This shows the cold spray patches that were placed at the cold test facility. I'm showing you these. It basically shows you that the validation that we can deposit a thick patch if desired. We're shooting for something greater than 1/8 of an inch thick, and we actually came up more like 1/6 of an inch we placed down. We also showed how you can overlap patches with each other. So there's no problem if you needed to butt them up against each other to either go over it again to add additional thickness, or if it needs to be extended, you can spray over top an existing patch. And then the larger patches were just to kind of show that, yes, the maximum widths that we can achieve with these systems. So the cold spray wall crawler has a maximum raster width of 11 inches. And then that can be kind of an unlimited length, because you have the cold spray system rastering across a maximum width, and it's just going to go step down and then it comes back up to build up those layers. So it goes down and back over. So the floor crawler, its maximum rastering width is 8 inches wide. So that's what that system has. So with that, I think that's the information that I had prepared to talk to you guys today. And again, I'm gonna hope that you can see, you know, the achievement that we reached in taking a system from a concept to a final product in a little over 2 years. And we can talk more about, you know, the tank integrity expert panel or our other collaborators, but I believe that we use a thorough and robust approach in our development, and also want you to feel comfortable in knowing that this technology is now out there and it's been perfected to potentially be used as a refurbishment method for Hanford's double shell tanks. So that's what I.
Question?
Yeah, before we go into questions, Josh.
Sorry. Yeah, before we go to questions, we'd like to give the regulators a chance to weigh in. So I would ask, is there anyone from ecology that would like to provide a perspective? Line over in the room.
Hello. Hi, this is Dana on virtual land. Thank you very much. That was a very interesting presentation. At this point, all we have to say is that we're evaluating the cold spray technology and its use with the double shell tanks, and are working with Energy to address any questions we have on this technology. But it was a very interesting presentation. Thank you.
Thank you.
Make sure, is there anyone from EPA that would like to weigh in? Now we can go to more questions.
Okay.
Start with Ed. You go to Chris.
So, have you thermocycled these over a period of time or any kind of separation process? Heat cold?
So do you want to talk to the thermal cycle?
Not specifically, but the batches have been out there in all elements for over 2 years now, or some of them over 2 years.
It's a long-term thermal cycle effect, we really don't.
Yeah. Well, the various applications that they've used it.
Okay.
There are no problems described in the literature, so. And the tanks don't really cycle that much. Yeah, generally, they're at a temperature range, you know, that doesn't vary more than a few degrees C. So that's,
But that size, you know, can have a lot of dimensional changes, just the sheer diameter.
and we started reprocessing waste again, we might be more.
Okay, yeah.
Question from Chris, then we'll go to Rob Firmly on that.
Do you have a standard powder composition that you use on all surfaces, or do you try and match the composition of the powder to the composition of the surface that you're going to cold spray?
Yeah, that's a great question. Thank you. So with that, we have tested different compositions of powders to see which ones perform the best with our set substrate, our carbon steel tank material. And that's why we performed those corrosion studies to see what would initiate corrosion or so it's not necessarily best that you use a mild steel on a mild steel substrate, which so what we have found was with the corrosion properties, that's where we down selected from the 8 to that one material that showed the preferential I showed that the 410L stainless steel had the least, or had the best, how am I saying this wrong? It worked out the best.
The best bonding properties?
Well, it had great binding properties, but then this corrosion properties, it didn't corrode. It didn't show galvanic corrosion, and it didn't show crevice corrosion. And so from that, that's what we're basing that off of. But then we go further than that. Once we find that powder, we then further dive into its microstructure, and we look at the annealing properties, the atomization process of the powder, which then assists in its adhesion, its porosity. So we really dive in a little bit further. I didn't answer your question though.
But your 410 stainless steel is the best you found so far.
Yes.
We are doing some more work, you know, TF said, please look at a few other things, so we're looking at a few other things.
And interstitial, granular, fresco, probably. Pardon? Granular, fresco, at the interface boundaries, do you seen any granular fresco? You're not quite in the city, I mean, you're not gonna have it.
There are compressive and tensile strength stresses, but they're so small.
I'm saying.
Question online from Bob Farmley, then we'll go to Larry.
Okay, I hope you can hear me okay. What I was going to ask, just based on your testing there, is this strictly used for external applications?
Yes, our applications would be on the outside of the primary tank. If you you could do it on the inside, but you'd have to, change your robot every time, but yeah.
Yeah, so this
Okay.
application is for inside the annulus only. And we're assuming that that's a clean annulus.
Okay, thank you.
Kind of a double question. First, have you tried this over an area that's actually leaking where there's chemical solution present? And that's the first part. Second part is, where can't you use it?
Okay, yeah, so the first question, so this application is actually not we're not prepping it to be used on an active leaking area.
Okay.
So this is like refurbishment mitigation, not repair. So in that sense, no, we haven't, and we don't plan to set that up, but what we are planning for is in case we do put that patch down, we do get through wall corrosion, and then that tank waste ends up touching our patch after all. So we have done corrosion studies with that using a couple of different simulants. We investigated that and saw that's the photo. There's one photo on there, but sorry. So we've actually studied and looked into that, because yeah, that would be a concern that we're interested in. Thank you.
If you look far and wide enough on YouTube, you'll find this one video that shows them patching with cold spray and actual leak. We don't intend to.
So how would you locate the areas that need to be patched? You can measure with an external instrument, right?
Yeah.
For the thickness?
Yeah. The areas that have been identified come from the routine UT inspection.
Oh, okay. Thank you.
Yeah, and to that point, this is, sort of, when we developed the technology, we developed it with the intent of eventually rolling into the larger DST integrity program itself. So the idea being, right, that as you perform your DST ultrasonic thickness examinations, you identify an area that warrants, this technology, we could actually go in and deploy that system and actually apply this material to the affected area.
You can't go under a tank, right?
No, this would be limited to the primary tank and the sidewalls, yeah. So,
Right.
and the floor, yeah.
The annulus floor.
Floor of the annulus, thank you. Yeah, floor of the annulus, yeah. We're not able to, the only potential access point to the primary tank bottom would be through the air slots, and this tool doesn't have the ability to go down.
Yeah. And surface prep, surface prep.
Yes, so there is, so the surface prep is what is performed by the cold spray crawler itself. When I said that we have a 410L stainless steel patch, it's actually, our feedstock is a mix of 410L stainless steel and ceramic blasting beads. And so for the preparation of that patch, we spray just the ceramic, two passes of just ceramic blasting beads, which removes all that mill scale and any residuals. And then we spray on top of that.
I'm surprised you're not using a laser.
We
Lasers.
interested in lasers, but,
Okay, so I have, a series of, lots of questions, of
Yeah.
course. And, can you talk a little bit about, the difficulties obtaining the right sizes of powders? Because, you know, I did some work on some submarine, or on some aircraft carrier catapults, plates. And we used basically plasma spray in those, and we were working in the nano phase area, demonstrating that through the naval research grant. So we had, but the problems we ran into were that the smaller and smaller the particles, more difficult they became, and more clumped. They had problems with feeding a plasma system. And the plasma system was very similar to the cold spray. So who are you getting your powders from? I mean, is the technology that advanced that you're getting nanophase particles in all those different alloys?
yes, it's wonderful. So I forgot the supplier's name, but we have a dedicated supply of powder with our specific powder specifications, the sizing, the formulation, like the specifics. And it took us a couple of years, but they have said that, yes, they guarantee that we have an ongoing supply. We've got the supply chain. But we did do a lot of studies before trying to validate which is the proper size particle, like the atomization process, you know, water atomized versus gas atomized. They actually spray different, and we found water atomized actually is better. And sorry, I'm a little excited. So we had a problem with our powder where we weren't getting a surface finish as nice as what we had been when we had ordered a new powder. And they said it was the same thing. The difference was the atomization process. So now nailed that down. So we now have
You're pre-drying or drying, you're heating the powder up?
So it is annealed. Yes, yes, it is being annealed. Mm-hmm.
Oh, very cool.
Yeah.
So, other questions that I would have is, when do you expect to deploy this technology? And, when would you be ready to deploy it, so to speak?
I think we're pretty much there at that point now. It's just a matter of identifying the circumstances and the tank to go pursue it. But I think we're getting to a point where, you know, this technology is mature enough that we've got opportunities to, in the near term, to actually go deploy this technology within the double shell tank system.
Yeah, we have, whitewater wastage, or at the whitewater zone inside the tanks, we have wastage on the walls that we've been reporting for years. Would those be most likely some of your first applications?
Are you speaking to, I think we sometimes call it the liquid air interface, right? Yeah. So that would be, you know, certainly under consideration depending on, you know, the specific tank that we're looking at and the type of, you know, thinning that we're seeing there.
Right.
It's just going to be dependent on, you know, whether or not it makes sense to go pursue that, or if there's, you know, thinning elsewhere in a tank that's maybe more favorable. So as we roll this technology out, continue with our UT scannings and identify potential candidates, something like that may be under consideration, but there's gonna be other areas like that technology as well.
So speaking of the UT, then we're still only a fraction of the square feet of area that is surveyed. And as we get we age and we do more and more rounds, we expand this and we get more information. And that's going to guide us to where to look. So once you spray a patch, the surface that we've noticed out there was quite rough, and including the sample you have there. It'd be hard for me to get a UT probe on that and get a decent reading with the interface. So how would you be repeating this to see your success or not success of the you know, how much more it's wasted?
Right. So what I did not bring the larger 12 by 12 heavier plate with me that was sprayed in May of 2024. that surface finish is smoother. It's similar to the surface. You remember the ones that were overlapping each other?
Yeah.
That surface finish there. So we have used UT probes to identify, or we've used UT probes to detect the total thickness of the patch and the wall. So we have shown that it is capable of being done.
I just see this as adding an extra interface. And, you know, it
So
always decays the signal and the quality of the UT.
Right, so we are gonna have to use a different transducer on our current UT probe, our UT crawler that's going down. We're having to change that transducer to get that signal, but it's using the same.
The lead light is on the expert panel. Figure out what changes in the UT program would be there. So,
Okay. Yeah, and you're actively considering these. And so then the last question I say is that.
on a very interesting thing.
But it's that,
Stephanie's, people are so fond of Stephanie. University of Illinois is developing a new guided wave system. So we've had started conversations with them that they're developing specifically for examining cold spray applications. So they just kind of popped up a month or so ago, and I said, sweet. So
yeah. University of what?
Illinois
Okay.
and Utah.
And Utah.
And Utah has always been pretty strong yeah. Yeah, and then the we're basically still on the sidewalls and no knuckles, no areas, reinforcements near, incomers or.
You could probably do the knuckles just because we haven't found any knuckles, because I mean, you can either spray vertically or horizontally. And so if you're on the knuckle, not too far down, right. You could just, be doing it vertically and just advancing up the wall as you go.
Okay. All right.
Do you have any information about how much need there is today for this product? I mean, how much you're going to be using it? Is it going to be used 2 shifts a day for 7 years? Is there a degree of knowledge of how thick or how thin the tanks have become?
The use, if we're doing an 8x8 patch and doing a 1/4 inch,
Right.
that's about an hour.
Yeah.
And so a lot of the areas that's thinning are like 2 or 3 inches. That they're great where they're of concern.
Are we, this is double shell tanks.
Yeah, double check that.
Is there a lot of thin balls on double shell tanks?
There, my personal opinion, but there are some. We like to take care of the ones that we have.
Okay.
Eric, we have another. But I think it's.
Well, I'm sitting here thinking about how much that machine is gonna be unused.
Well, what we're doing now is buying the service. And so,
Yeah.
so the basically, it'd be not up to us, but when operations gets comfortable with this, they can make the decision to continue the service or to,
Okay.
buy a system.
Yeah, and the other thing is in their reports, on their NGE reports, they have rollouts of the tank and where the areas are. And so those are very valuable in understanding the wastage on the sidewalks, yeah.
So it looks like Chris has been patiently waiting over there to ask a question. You guys keep jumping in, so.
I think you answered it. I was gonna ask you, what's your rate of spray in terms of like square inches per minute or square inches per hour? Is there a standard, do you have a standard rate that you like to use?
The rates that we have is that basically we put down a 2 mil layer each time. And so we did 75 passes in a 4x4, and that took like 45 minutes.
Okay, and is there a maximum size that you can spray a substrate depending on?
The width is depending on the raster, but you can keep on moving the robot in one direction.
And you can refill that powder feeder. So,
On a continuing basis?
yeah, so you would need to power it down
Okay.
and then add more powder to the powder feeder and then bring it back up. But that process does not take that much time.
And for one powder feeder full,
Mhm.
what's the size you can? 8x8?
I forgot what the
You
thickness
probably,
is.
yeah, we've done 8x8, the one we did in, on the floor was an 8x8.
Yeah.
And we didn't refill the powder bin.
No, it didn't. But yeah, sorry, I don't have the exact numbers for you because we've done so many different sizes, but thicknesses also, so I don't.
But Kyle has expressed, pounds per hour and stuff like that.
Yeah, I should know.
Discussion. Yeah. Well, but we can get that information as well.
Yeah, I've got that written down, Chris. I'll follow up as soon as they have that information for you.
We have a question from Matt online.
Several, if no one else queues up. Let's get started here. So I am interested to find out, and I'm happy to see that you're at a pretty high technological readiness level. With the DOE rate that at a 7 or above, it's pretty much ready to go in the fields, what I was hearing.
Yes.
Yeah, I don't know if we passed it through the formal technology readiness level evaluation process, but it is fairly mature technology at this point.
When evaluating this technology, was there any thought put into its capability, say, in retrieving AY-102, the double-shelled tank that has failed?
So I think, initially the question was asked, it's a good question. I think initially we thought about that. Some of the testing we did, found that it's not very suitable for two reasons, right? Well, for one, AY-102 had a failure of the primary tank bottom. This technology is not able to access the primary tank bottom. And on top of that as well, the technology itself was designed more so to provide additional material thickness to an area that does still have, material present. When you start dealing with holes and gaps that AY-102 had at the bottom of its tank bottom or the primary tank bottom, it becomes significantly harder to bridge those gaps. I don't know if that sounds about right, Stephanie. Yeah. So I think that the thought crossed our minds, but through some of the initial screening we did, we realized that it wouldn't be suitable for that application.
Yeah. Well, that leads me to my next one then. When in design and evaluating these designs and changing it up, what considerations, now you're not expected to go into a contaminated area all that often, but what kind of considerations were made for decontaminating this equipment for reuse?
So this equipment is going to be going into tank annuluses that are presumed in the beginning. Okay, so we're not going to be taking this into any contaminated area of the tank. We do survey it out after, once it comes out of that annulus region, we do survey it just like we survey our existing UT crawlers that we utilize in the tank annulus. So we are definitely looking at, the contamination possibility, but there's no intent to put it into a contaminated zone.
Okay. And my last one, and this is more of a materials issue. When you're spraying this material, what is the homogeneity of the mix when it's sprayed on? So what I'm trying to say is, how chaotic is each level? And when I know it's pretty advanced, if you're looking at a microscope, do you see ways that it aligns so that they're not cracks in the material, but gaps from where each individual particle may not have touched each other completely? That's kind of difficult for me to say, and I don't know the precise technological terminology.
No, that is great. And I'm trying to see if we could advance the slides. I think it's slide 3. Could you?
Yep, I'm working on it.
Okay. Okay, yes, that's the slide. So if you look on the right-hand side, there's a black and white image. And what you're seeing there, I have denoted TC 128, that is our mild steel. So that is what's representing our tank waste, that's what's representing our tank liner material. And then you have 410 LSS stainless steel. So you can kind of see a division where those two materials, you can just see like the 410L stainless steel, you see black dots in there. So those black dots are voids or part of our peening material, which is a ceramic blasting bead. So you can see the porosity of these samples. So that's what we do with these coupons. We take a thickness measurement, we look at them visually in the field, but then we take them back to the lab. We section them off, we look at them underneath the microscope, and then we calculate the porosity of that material. So what you do have porosity. It's right around 1% porosity, and that's very good. And I want to say porosity that word might scare people. These pores do not actually form a connection with each other. So it's not that this is a porous material though. But yeah, to answer your question, I hope that answers your question.
No, that does help, and the term porosity certainly helps me explain what I was looking for as well. And the black dots, that's exactly what I was looking for. Is could there be a potential path for something just to sneak its way over time? One thing that might be handy if you're to put more on this slide would be a scale. Like, is that in micrometers, nanometers? What is that bad boy in?
10 microns?
Yeah.
I'm thinking 10 microns.
Okay.
Yeah.
That's everything. Thank you so much.
It doesn't help you at all.
Yeah, it makes those small.
10 mics helps me.
It's about like that.
Other questions in the room or online?
Doesn't look like it. So thank you, Stephanie, Kale, Eric. We appreciate you coming and sharing the information on this technology.
Yeah, thank you for your interest.
Yeah, thank you.
So you're gonna add to the end of life.
Yeah, I mean, ultimately, this is, to help maintain the fleet that we've got, right? That's the end goal here. That's the whole point of the tank integrity program. That's another tool in our arsenal is to make sure that these tanks can support the waste treatment mission.
So will the state agree with this and with regards to the code and structural?
Probably not prepared to speak on behalf of the state at this time, but certainly it's something that we've talked to them about before and they're aware of.
It looks like Dana had shared Ecology's perspective earlier that they're still evaluating. So
Yeah.
All right, I think we're coming up on a break.
We're a little early. How would you like to see it? Take an early break, take a longer break?
Maybe just an early break would be good.
Just a quick 5-minute break and then we'll get to a discussion and then we'll get out of here.
Maybe a little longer.
Okay.
How about we?
So like for being the chair.
My personal interest. How about we turn at 3:05? How's that sound?
Perfect, thanks, Josh. Thank you, guys.
Thank you.
Appreciate it.
Thanks, Kim. Thanks, Kim.
Yeah.
With that, we're live again.
All right, Rob, you're up.
Oh, goodness. First of all, I want to thank DOE and especially Lindsay and the rest of the staff there. The last few meetings and presentations we've had have just been tremendous. Really good, hitting right on the mark. And so this is the time where the rest of the group can start speaking up a little bit on what they really want to do. I have on the last page of the you have our last month's TWST meeting minutes and handy and the very last page.
Can pull those up? You want to keep that?
Please, yeah. I have to mention that earlier. So anyway, I have gone out and emailed a lot of folks on the committee and had asked. There are more topics that people want to talk, and we've got time to talk about them, time for the presentations, or people to present to us. And so I started shopping a list around and was getting comments from everybody on what they wanted to hear from the standpoint of tank waste. I put them together. They're in the first appendix, or the one and only appendix of that.
These are your key focus questions?
Yeah, the key focus questions. Yeah. Exactly. Okay. Here we are. Okay, so we had some key focus areas that people had suggested that we would like to have discussed in our committee or with the leads committee or the home committee. And so I went down that list, and if we can take it's there right now. And let me just read it to you. We need a little bit more definition of the West area management, risk management process. We've heard that it's going to involve building a second modular cleanup system, and then ship that liquid over to the east area. So, so I think getting more information on the waste area management, excuse me, waste area risk management issue.
Wednesday, the one over here, I have a.
Okay. I'm watching it there.
Okay. The second one is, so in our last few tank integrity presentations, we've been a lot of show about how they're getting measurements and things of this sort. There was some discussion among some of us wondering about, well, what does it all mean for us? What does integrity determination mean? What is the estimated remaining life, and how are they determining it for the tanks? And specifically, when they point out they discovered falling concrete in the domes, eroded rebar, cracking on the bottoms of the tank. I think that we need to ask more questions is, when is the tank done? You know, where is it happening? Because letting it go till it leaves is it's kind of against the WAC code for sure. So, and today, of course, we do have a presentation of new technologies that they've been developing called the cold spray, which was a real good issue that we got. Other new technologies was teased to us was the potential for dry tank retrievals. In other words, drying out a tank and then putting a little tractor in there and scooping everything out, or doing it pneumatically. Fourth one on the list was, and we really got this one today with cold spray. We were tracking some progress being done at Savannah River on repairing the tanks, and learning about the cold spray is a real positive thing for us. We also had a request to make sure that we get the lessons learned from LAW startup transferred over to the high level waste project. The next one on the list was there was a discussion of DOE advertised that EM and Bechtel had a new plan for the construction of the high level waste and to minimize the cost and schedule. We should think that that should be kind of high on our list of understandings. Another one that we had, and maybe Chris, you can explain this next one, your request for the conduct of operations and description of the system descriptions. for the LAW or DFY facility.
There wasn't so much conduct of ops, although that's a major part of it. But we've heard a number of times at DOE that in the DF law, there are 25 separate subsystems. And my concern is, how are you going to get all of those 25 subsystems day in and day out to routinely work in sync with one another, where you don't have one subsystem shut down, something go wrong, and you have a domino effect and it shuts down everything upstream of it. So process control is a major concern. Consistency of operations, which gets into conduct of operations, where you're doing the same thing day in, day out, 24/7 for 40 years. All your subsystems are working perfectly in sync. With that many subsystems, it's not straightforward to assure how you're gonna get consistent operations over long periods of time. And I know from when I was in the oil industry, I had a little bit of exposure to CITGO's refinery operations, and they have something like multiple hundred of subsystems working that they have to, and it's a major problem. And that refinery had a process control group of 100 or so people, just to keep all the subsystems working. I'm kind of wondering how it's going to work here. It may seem simplistic, but it's really not.
That would be a Matt Irwin thing, so I will take it to Matt and see what he can come up with.
And the last added on to that is kind of an explanation of the ISMS process at the site and how it works. Okay, the next request we had was an update on the TSCR performance. We had somebody report to us last meeting that it was producing contact handled radioactive material. And so we need a better explanation of what the quality of the water is that's coming out in the TSCR process. So we still, grout is still an issue. And I know you're working really hard to do something there, and I won't hit on it anymore other than it's still an issue.
Yeah, I know that that's one that you guys are itching to get, and so as soon as we have something available, we'll bring it forward. I would anticipate an update on what the timing is on that early next year. So that is that one, and then again, I see cross-site transfer lines coming up. That one I was told at the end of FY25. They said we can put it on the work plan, but at the end of FY25 is when we should be able to bring a briefing.
I have another item on ground I'd like to put on the table too. At the 5-year plan last night, we heard that the schedule called for all 2,000 gallons of the test bed initiative to be shipped for the end of 2025. What doesn't appear anywhere else in the 5-year plan is what's going to be the end product of this exactly. How will results, or when will results be made public? What decisions will be made on the results? So on and so forth. So what's the end of this project? And will the public be involved in any way, shape, or form? I talked to Del Mar a little bit after. I'm not sure he understood what I was getting at. But I think it'd be good to have some type of presentation somewhere or some informal discussion about what will the end of this project look like?
Yeah. The documenting of the TBI results is going to be very important, and having a report on those.
And Del Mar said, well, the analytical results, we should get those by the middle. I said, well, I'm not so concerned about the analytical results. I want to know, the disposal results, the grouting results, all that stuff at the end, which is what a lot of concern is being voiced about.
Okay. Yeah, I can take that back and see what we can bring forward on that.
Yeah, I wish I don't know if you can ever do this, get us a tour of
Permit
If you can get a tour of Permafix, you can tell me how to get a tour of Permafix. That's not something that we can set
Okay,
up.
so we need to talk to the president of Permits Act.
I don't know how you
Whoever it is.
would go about that, but that's not something that department can set up
Okay.
on your behalf.
The reason why I'm saying that is that I feel that, we need a little bit of background behind what it takes to make a grant. Okay, what are they doing? What are they doing with the quality assurance and that sort of activity?
And then, go ahead, Matt.
Isn't there a DOE team that is researching different grout formulations?
So there is a grout team. However, I know we've talked about different formulations and how a lot of that is proprietary to our subcontractors. So, not necessarily something that we can come share in a public forum.
Okay, but I've heard that there are some formulations that the words that it said was like, it's getting to the point where it may be as good as glass. And it'd be interesting to learn more about that. But if it's proprietary, yeah, understand.
And, you know, it's good to have these conversations at this level because when we go back to our subject matter experts and say, hey, they'd like a briefing on grout. Well, what about grout? So I think that just getting this type of input at this level will help us better frame those briefings and ensure that we're providing information that you guys are looking for.
And I read in AR, and I don't remember the number of it, that different waste compositions require different formulations of grout, because some are acidic and some are basic and some are metallic heavy and some are, and that kind of flies in the face of a contractor coming in and saying their grout formula is secret, unless they'll provide test materials, you know, to assure that grout is stable and solid. And I talked to a couple of the DOE guys during our tour about grout, and they kind of implied the same thing, that one tank may be fine or 4 tanks may be fine, but the same formulation does not work for everything unless there's some magical thing there. And you know, I don't know magical things very well.
Yeah, well, unfortunately, I am not a grout expert in any way, shape, or form. So, yeah. But I don't have a lot of like technical input or be able to respond to questions or stuff like that because I don't know the answer. But Chris, do you have something to add?
Yeah, I've written a paper on grout basics. I ran it by Rob and Rob was good. It might be called grout primer. And I've almost got it all into a PowerPoint presentation. And it's not about grout at Hanford. It's just about grout generally, a few basic concepts so that people on IM team or people in here have a better understanding of some of the basic concepts. It has nothing to do really with Hanford. Hanford isn't mentioned. Tank farms aren't mentioned. It's not pushing for grout. It's just everybody should have some technical understanding of why grout works, what some of the problems are. And I put that together in a paper and PowerPoint presentation. And this is something that somewhere down the road, I'd like to give to this committee or to the IM team.
Let's talk about that.
Yeah.
I understand.
And I don't have to send it to Washington. I don't believe they have it approved.
Yeah, well, typically when it comes to some type of technical briefing, we will have our technical experts bring in those briefings at the subcommittee level, but I think at the IM team level, it would be more appropriate for you to give that brief.
And I learned during the tour that most of the grout that has been used on Hanford is almost popcorn like grout. It's almost like the foam you stick flowers in a pot, only it's heavier. It's not concrete. It's
no, but explain the function though, in that there's different grout mixtures for like void filling, okay, versus immobilization.
Yes. Yeah.
And stuff in the immobilization is made differently or has a different.
I'm sure that's right.
And so there's a lot of different levels in that, but Again, the one thing to understand, and we shouldn't get confused, is that all of our waste is alkaline. Okay, I mean, there's requirements that it be at that pH 10 and above, okay, to transport in our piping system. So it's all alkaline, and it may be 12 in some cases. So, and yeah, the grouting, but that's why we need a good discussion from DOE or its people and talk about how, the grout can be used successfully and also, you know, if we were gonna advise the site on anything with it, I think we can all agree that we really don't like the liquid transporting, you know, down there, but we may accept it with the guarantee that we're gonna get our own grout plant as soon as possible.
Well, I think that as soon as we are able to bring a grout briefing, which we will follow up with our team after this meeting, probably, to be honest, next week, to see when that timing is appropriate, then I think it would be good for the committee to have that conversation on how to respond to that request for potential advice on grout, because it is my understanding that not every seat on the board is supportive of grout. So we want to just make sure everyone has the opportunity to have their voices heard.
Right, exactly. That's.
I don't know how you can say that. Not everybody on the board is supportive of grout.
How I can say that?
I don't know how.
Okay, so, the other thing is we'll probably need an update on the advanced, AMP system. And and yesterday's meeting has kind of cleared up a lot of stuff for me, is that, they were talking about having a similar to an AMPS put over in the west area, risk management area. And so, so maybe we could make sure that we get that update that talks about both of those.
But yeah, when did we have Janet come last? Because Janet Dedeker came and gave us a briefing on the AMPS, I think in the spring timeframe was it in June? Or May?
I feel like it was.
I think it was in June. So we'll follow up with Janet and see if there's anything new that we can share or when she anticipates something that.
Yeah, I think she teased that the contract was gonna be going out for March.
Oh, I'm looking at the email I have from her, her briefing is from May, so, looks like May 13th.
I think we had full board in May, so it would have been.
It would have been the June, yeah. Okay.
So the last two items on this, we can cross the bottom one out because we did get a tour of the cold test facility. Thank you very much. That was good. That was a real good, request. And, the other is really, when we hear about DOE's confidence in the cross-site transfer piping ability to do its job and to reactivate it. But I think we need some more discussion with that and more information how, 50-year-old, piping system can meet today's codes and standards and see what ecologies weigh out of it, whether or not they, have to take exceptions to the WAC code in order to use that piping.
So per Richard Valle, end of FY 25, we should be able to report that briefing.
Does anybody have any other desires on subject and talking and things that we should be thinking about?
This is just out of curiosity, it'd be for information purposes, no advice coming. But I'd be really interested in the mechanics of exactly how feed material and vitrification are going to be added to slurries and then put in the mixture, and whether or not they're anticipating significant variations in the feed in the slurries, such that they have to have significant variations in the amount of feed material that go into the melter. And the computer system that will control this, I know because I've read on the analytical part of it that slurry composition will be analyzed by the lab. That's sent back to the control room, and that the feed material is adjusted based upon the composition of the slurry as determined by the lab. But I don't know if this is per tank, per 1,000 gallons, per whatever, exactly how all that works. I think it'd be an interesting presentation.
Plus, they've had problems with the feed system. That former feed system does not work for long. They have to redesign it. And that's, but also, I think, fit into that.
The,
But it's been redesigned.
the
It's been redesigned, it's not installed, it's not built yet, has not been tested.
Brit used to come in rail cars and went into, some silos and the feed system didn't work. They've now switched over to bag Brit and it's coming in by truck. And Lindsay, we need to talk about traffic safety regarding trucks.
Same thing.
After our visit with the IFS people and ERDS people, there's gonna be a lot of truck traffic in the future that we probably need to look at with somebody.
I think that we'll probably see that more in the LID committee, but don't like that,
That's
that we could do like a joint briefing on it.
Yeah,
If this committee was interested as well. It looks like we have a couple people online that are in queue. Josh?
Matt and then Dan.
Just a couple things I was thinking of in regards to the great work Chris has done with his grouting paper. I'm considering maybe putting the NRC requirements for grout and grout disposal in something like that might help some of our members understand what is necessary before something goes actually into the ground. Also, we've been talking a lot of these interdependencies, about the DF law and its 25 subsystems. We have new members as well. And I didn't see this on a plan, but I've been thinking about more and more, especially when it comes time for the next system plan, about getting a presentation on how the system plans are made and all the assumptions that go into them. Me personally, I found a lot of value in going through the system plans and understanding how all these things are interrelated and how they work together. It might be something very handy, especially for our new members, if not me again, and for us to make sure that the HAB or this committee gets whatever advice we might want to include it into the next system plan. And obviously, as a representative from Oregon, I'm very, very interested in grout and the cross-site transfer lines as well. One other thing that I've been noticing, and perhaps this is a new issue, but there have been numerous GAO reports recently that affect Hanford and us tangentially. And I'm kind of wondering, I might appreciate, this might be for a different committee, but how the DOE works with GAO and answers GAO questions and lessons learned from previous ones, because I know in this most recent, while the DOE agreed with 2 of the GAO recommendations, they did not agree with the third, and I'm predisposed to agree with the DOE on that one in particular. So if that's a big shock to anyone or not.
So Matt, for the system plan question, I can take that question back to Jim Lynch. He was the department's lead. I believe it was Dan McDonald for ecology. I can't speak for ecology, but I'll ask if that's something that can be supported. Now, as far as how DOE works with the GAO and interprets, I guess, which recommendations to accept, can you help me understand how that would help guide policy level advice, or is this just something that you're interested in understanding?
I haven't thought deep enough into it to understand what kind of policy level advice the HAB might offer outside of when there's a recommendation, especially when that recommendation might not be agreed upon, that there's some discrepancy between the agencies. Whether the HAB could be useful is to say, no, we either agree with the DOE on this one, or we agree with the GAO, and here's our rationale why. But that might be a little backwards looking by the point we see these GAO reports anyway.
Okay, and then Josh, is Dan McDonald raising his hand online?
Yes, I was gonna suggest we jump to, I think Dan may have some context to provide.
On the system plan, I would offer that it would be beneficial, and I certainly would offer for ecology to be part of information. Matt and I have talked about system planning before. I'd be glad to help anyone else with a better understanding of system plan, where it came from, how it's used, and some of the decisions that we go through to get to the assumptions. One caution though, folks, please remember that the system plan is not a decision document. It's an informational document. You can suggest a variety of scenario inputs. We will take them, take a look at them, see how we might be able to use them. But the system plan is not in and of itself a decision document that DOE uses to allocate their resources. As far as the GAO report is concerned, I'm not sure, Matt. I would need more information to understand your perspective on that. The GAO is an independent body consigned by Congress, so they don't directly have influence over either federal or state. They report to Congress directly.
Yeah, DOE is not obligated to implement what GAO says.
All right, next question.
And Dan, what are your thoughts? Or Dan Phillips, what are your thoughts?
Yes, thank you. I'd just like to second Chris's suggestion that we better understand the process of making glass. And it's after 22 years in the particle board plant, I know blending is where the magic happens. If you don't get it right in blending this, no matter what you do down the line, it's not going to work. So I think we really do need to understand the slurry process and the mixing process, the conveying process, and the whole schmear. And I think we would then be able to come up with some useful advice. Thank you.
And that in particular would be beneficial to understand the systems in the LAW facility. If we understood those systems, we understood there's a prep tank and a feed tank, and they operate differently and where they're getting their samples from, that would make a little difference in our understanding how glass is being made.
So I feel like we've covered all the questions we have in our potential future presentation.
Is anybody, yeah, I was gonna say, this is the time when we can, if you go ahead and we get it on the list, and then I start talking with Lindsay, and if not, will not be this year, but if we, like she said, we'll have something for the 2025 year plan. So.
Matt, online has some more thoughts.
Well, another thought. Oh, actually, no, it's something Rob brought up. I believe it was yesterday, if I'm not mistaken, and you spoke a little bit about the direct feed high level waste. That might be further out. It's looking like we got a pretty full calendar, but looking forward, direct feed high level waste, how that changes the potential feedstock and what can at least start the high level waste process, how that will work different than the standard once they have the let's not say pre-treatment, but pre-feed buildings built.
Thanks, Matt. So I think that the Tank Waste Committee has a very robust work plan, and I have lots of input from you guys on how to frame these briefings. So I apologize, I'm not prepared to provide input on what is confirmed for January. We simply just have not had time to nail that down, but I'll make sure to be working with Chris and with Rob as we plan for January.
You know, on some of these, we might not necessarily need a formal presentation in terms of PowerPoint, but getting people just to talk informally where you don't have to send things up to Washington and get 11 office sign-offs or something. Some of these topics, I think, would be quite amenable to the informal type of discussion. And could maybe be done a little bit quicker without 6 months advance notice or something.
Did you guys like the format in which Ben Vanna presented this morning?
Super.
We'll try to do more like that. The plan for Stephanie's briefing was to not have any slides, but then she thought the slides in hand, so, we last minute got those ones pulled
Did
through.
it serve as a reference for some of the questions that's,
Yeah,
if they're not able.
absolutely.
Yeah. Well, I guess I'd like to remind folks that, there's, September 30th through October 31st, we have a 30-day public feedback period for the 5-year plan. So if people want to, write individually comments, or if people want, team on my comments, just give me a phone call and I'll just put my comments in. We're doing it as personal as opposed to as the committee.
On a related note, talked around that, last meeting. Chris volunteered to lead in the HAB's advice on the HAB's fiscal year 27 priorities.
Yes.
So I would suggest that if you have thoughts, comments, priorities to submit for the TWST committee, then we meet on November 7th. For the kickoff meeting that Chris will be leading.
I've asked Josh to put out an email to members of the HAB and other committees who weren't here this morning or this afternoon to see if we want additional members on the IM team. And when we get that, I talked to Lindsay about IM calls and a kickoff meeting. I'll put together a timeline and send it out to everybody that has volunteered for the IM team and what we want by when. I'm gonna be out quite a little bit at the end of November and through mid-December. There's a lot of time to get things done before that. There's a lot of time in January, but in mid-February is when we want to have to approve our product because we want to get that to DOE in time for them to think about it, incorporate it in the budget, in their budget that goes to Washington. And we also send it to congressional leaders and people in Washington too. So we wanted to get it out of here in February to be in sync with the DOE budget cycle.
Buying teams. Stepping back a little bit, we talked about the system plan and what you might like to provide. Several meetings ago, we gave our system plan IM team member the homework assignment of reviewing the previous system plan and thinking about what scenarios aren't in there that you would like to see in the next one. And they were going to bring this to the next, or perhaps the first system plan IMT meeting. We have a dedicated day on November 7th for IMTs to meet. Does that sound like a good time for everyone to bring their input?
Just so a little background there. They've been issuing these system plans on a pretty regular basis for a number of years now. And then we learned through the holistic negotiations that they won't be issuing one every 3 years, but issuing one every 6 years, potentially. Especially, and they did that because many things just don't change that much, and they just, and I can understand trying to reduce that, but I have problems. There's just like too many options. You got the FFRDC options, you've got the AOA options, you've got the system plan options, you've got, so many options. And then we get our 5-year plan, and our 5-year plan doesn't really relate to a lot of what all those other things said that we should be doing or suggested we should be doing. And so it's kind of troubling that our system plan now seems to be a make work, that if we're just making work of it. Because everybody's got their own potential option, but they're not going to use any of them. Because they're already on their path, they're going forward. And so, I just, when I went back and I started rereading that again, last month, I was had a lot of time to do that, and, you know, I just see the same stuff all the time. And it's, I don't know what I've learned new in this system plan that I didn't know already.
So for timing, Rob, I heard you ask for a system plan briefing from the department as well as ecology. And you want the IMT meeting, would you like that in November or after a potential briefing on the system plan development process?
Are we gonna get a briefing in November?
No, because November is the board meeting.
Okay.
And we're not briefing on system plan in November.
Okay.
324.
I think let's go ahead, let's get a meeting down, let's talk to some people, see what the potential concerns are. I'd like to hear what other people think. What do they see that's really good about the system plans that's different than in the past? I would really like to hear that, so.
I think a 1 hour meeting might be appropriate for
Yeah.
that, for folks to open that conversation.
Yeah.
I would like to know, why is the number of canisters and the amount of waste be processed in this system plan roughly 50% less than in the previous system plan?
Good question.
That's a big difference.
Yeah.
And a large part of that is the different ratio going to LAW versus HLW.
The entire team is either in this room or in the virtual room. Is there anyone else that would like to join this team to potentially provide future input? Plan?
You got my name on there?
There's already an existing,
Yeah.
some people already on the IM team, right?
Yeah.
So currently it consists of Doug, Chris, Larry, Matt, Mia, and Susan Cole. Yeah, so everyone knows their homework assignment and they'll be ready to participate in the IMT meeting on November 7th, right? After any questions, we don't know what we write for January, so we can't eventually plan yet. What else needs to be covered in the business?
Good Halloween. I don't know. No, I can't think of anything right now. And I think the last couple of days have just been almost overloaded, especially last night. That was a very good work. And the other thing is too, is, you know, we've been asking for years for more transparency, more information. Well, I think we're gonna really need to give Brian Vance a pat on the back, because this 5-year plan approach that he's implemented here for us is really showing a lot of continuity in the projects. And I think it's a really good thing. Yeah, I find great guidance in that 5-year plan. Yeah, it's good.
One thing about the 5-year plan that I think would be good for everybody to think about is when you look at 27, 28, and 29, there's nothing in there about DF law operations. Nothing in there about pump and treat operations. So it's like, if between pump and treat and DF law, that's gonna consume an awful large part of funding that the site gets. But there's nothing in it in the 5-year plan. And if this is gonna be par for the course, once something gets into operations mode and it's day in, day out, then it's not worth mentioning in a 5-year plan. Then at some point in time, there's not gonna be much to a 5-year plan in the not too distant future. So what I'd like to suggest, and I'm gonna put this in as a comment, is I think in addition to risk reduction infrastructure, whatever, they ought to have a section there on operations. Where they can say, in these operations, our goal this year is to meet these goals. X amount of gallons per minute through the pump and treats, X number of canisters per day, so on and so forth, so that the public is aware on an ongoing basis that what operations is doing and what it's doing for the money that's going in there. Otherwise, it's kind of this big hole. We know there's money going in there, but it's not mentioned in the 5-year plan anywhere. So I think that 5-year plan needs a little bit of rethinking as we get more and more into an operations mode. Something needs to be mentioned about operations and what operations is doing. Even if it's just saying, we're meeting these specific goals day in and day out, or we're going to process this amount of this year, treat this amount this year. I think that would be good to know.
The 5-year plan, I was noticing that on the bottom right-hand corner, there's this section that talks about
There was a little bit,
like things that were treated.
there's a little bit in that, but I'm thinking that ought to be elevated somewhere
Yeah,
in the work that's done,
okay,
because it's easy to miss.
yeah. Yeah, I was glad it was there, but yeah, seriously.
And I think there are other aspects of operations that could be mentioned too, expanded above and beyond that. For example, pump and treat, they say we're gonna do 2026, 3,500 gallons per minute. But how much hexavalent chromium would they like to remove in 2026? How much carbon tet do they want to remove in 2026? Kilograms of carbon tet. And you could probably have similar things for if we build grouting for grouting, if we call vitrification, but there's a number of goals that they probably want to meet. And I think those things would be good because they involve a lot of funding that the site's getting.
Yeah, we're doing good work, talk about it, right?
Right.
Yeah.
And there's nothing in it for the last 3 years of that 5-year plan.
Okay.
Any business or thoughts to share before we close this out?
I don't think so. Well, thanks everyone for your attendance and Rob and Chris for having a very efficient meeting. We did a little bit early, and Josh, thank you so much. So thank you. This meeting's adjourned. Thanks everyone.
Thanks everyone for coming.